start recording. So we're going to find the value correct to 2 decimal places. So let's start underlining those things. And the other thing is, obviously, we'll label our triangle. This is C. Doesn't matter which sides, A or B. C just has to be the hypotenuse. Okay, now the other thing to just double check is that they're both in the same units. If they're not, you need to convert it to whichever one that you've been asked for or you're going to use. So here, if I wrote out the formula, so this is Pythagoras' formula. So if I substitute in, it would be 6.1 squared plus 5.3 squared. Because you have your graphics calculator, you can always just use the solve function. So you just write your formula out, doesn't matter where the unknown is, and go comma x, and we'll get that answer, which is, now it said 2 decimal places, so I get 8.08 centimeters. Now, the thing I'm checking here, I know this, I was finding the hypotenuse, so it should be larger than the other 2 sides. That's a way to know if I haven't stuffed it up, and it's right, so that's correct. All right, let's look at this one. So if we label the triangle, this one's the hypotenuse, this is A and B. So if you wrote the formula out, now it doesn't matter when we're using the solve function where the unknown is. So all I just have to do is type that into the calculator instead, and we'll just use solve. And just remember, you just want one y, so you just do comma y, and you end up with y equals, said 2 decimal places, so y equals 6.53 centimeters. There we go. Now this one down here, they didn't have the diagram, but I've just quickly drawn one in there. So it says find the area of a square with a diagonal length of 6 root 2. So if this is a square, the sides are all the same. And what they're saying is this diagonal length is 6 root 2. Okay, and it's saying we need to find the area of the square. So remember, area of a square is actually the length squared. So this side L is what we want to find. We need to find. So you can use Pythagoras. So really, if I use the Pythag formula, and instead I'm just, this is C, so I'll put that in the calculator. Now I've got L squared plus L squared. So it doesn't matter if there's 2 unknowns, it's the same thing, it's the same letter. So the calculator can work it out for you. So you get L, equals 6. Okay, so therefore the area equals 6 times 6, which equals 36. They didn't say what units, so I'll just say squared units. Because I didn't give a centimeter or anything in that example. So that's all that is. So you might, if you get a worded question, maybe draw a little diagram. You know? Okay, here's our exam questions. So they're asking me to find the length xz. So that would be here. And that's the hypotenuse in my right angle triangle. So all I have to do is type in that into the calculator and just do the solve again. So just solve, comma C for this one, and I get 45.37. So D, I'm going to go 45 point thing. That was a multiple choice. Now this one, a closed cubic box has a side length of 36. So what you got here is a cubic box. So when they say cubic, they're all the same size. So if I draw out this 3D sort of image here for you. There's the cubic box. All right, so if I did this, hopefully you can see a cuboid there. Now it said it contains a straight metal rod, and what's the maximum length a rod can be. So if you're going to get the biggest rod inside a box, it'll be down in the bottom 1/4, and it'll go to the opposite top corner up there. Okay, so it's sort of inside the box, you can't see, but that's where it's going, like that. All right, so what you're going to do is you need to find, that's a triangle here. So if I draw across the bottom of the square floor, and then I'm going to draw this height of the box there. So really what I've got, and then I'll just draw it in a triangle form, flat, that's what I've got there. So this is the rod I want to find. Now this black line, they said they were all 36. So this is 36, 36, and that is also 36. So I know that's 36. So I actually need this purple one to be able to use Pythagoras. So what I can use on the floor of the box is you can use that right angle triangle. So I'm going to use along here and along here. So I've got that and that, which is 36 and 36, and then along there, this is what I'm calling X over there, is X. So I can use Pythagoras twice. So first I'll use here, I'll find what X is. I'll go X squared equals 36 squared plus 36 squared, and you can do solve in your calculator, and we get that to be, say, 50.91. So now I know that this is 50.91. So then I use Pythagoras again, where I'll go the rod squared equals that 50.91 squared plus 36 squared, and you can do solve in your calculator again, and we'll find out that the rod is say 62.4 centimeters. Okay, so that's good, it's bigger than the 51, so that's how we find that one. These ones are called sort of 3D Pythag. You'll do a bit more later in chapters, but just to show you now, I'm sure you've done them already. They the challenging ones of younger years. All right, here, pretty easy. They want me to find the distance here, this CB, but if I used this triangle in here and I just called X, well, I can see that CB must be equal to 2 X's, because there'd be an X, the same triangle there. So I'm going to go find X using this as C, this is A, and this is B. So I've got C squared equals A squared plus B squared. So 14 squared equals 8 squared plus X squared. You can use your solve, comma X, and we find out what X equals, which is, I've just got the exact answer, sorry. So it ends up being 2 root 33, but we want 2 of them. Okay, so our answer ends up being 45.9. Okay, meters. All right, so that does not look right. I'm going to stop that there. Okay. All right, we're fixing that up. So we did get X equals 2 root 33, which is approximately 11 point, we'll just say 11.5. So we've got up here 2 11.5, so that will equal 23, okay, meters. Yeah, that looks more sense. I don't know what I was doing. I think I might have been looking at another calc, but it was way too long. I'm thinking it made it bigger than the hypotenuse, so it couldn't be that. Here's another 3D one. So with the square base pyramid, you need to find the height. So often I would say you sort of try to get the flat diagram of what you want. So here I'm going to have to use that triangle that I've just drawn out there. So if I draw it flat on the page, I've got it like this and like that. So this is 8, there's the right angle, and I'm trying to find the height. So to be able to do that, I'm going to have to get this little distance here, which I'm going to call there, x. All right, so that means I need to be able to get that x some other way. So if you look, you've actually got a right angle triangle on the floor of the square base pyramid. So here, now, because they told me it was a square base pyramid, I also know that that is 7 centimeters here. Okay, so I can use this square base where I've got 7 and 7, and what this line across here is this line across there. So x is obviously half of that. Okay, so let's find this purple one or whatever along here. So I might call it y. So it'd be y equals 7 squared plus 7 squared. Sorry, y squared. And you can pop in solve and we'll find out what y equals. Just going to do that. So I get 9 point, I'm just going to round. I'm going to say 90. Okay, so we get y. Now x is half of that. So x equals y divided by 2. So x equals 4.95. Okay, so now I've got 4.95 I can put up in here, and then I'm going to do the same Pythag rule again. So this is C, this is A and B. So I'll have 8 squared equals h squared plus 4.95 squared. Pop that into solve and we'll get our answer, which will be h, the height will equal, I'm just going to round, 6.3 centimeters. Okay. All right. So there's another 3D one. 3D ones are generally 2-step with Pythag. All right. I won't do the actual calculation, but here they want the shortest distance, which would be along here. So this is where you set up Pythagoras. This is our hypotenuse. So it would be 1.5 squared equals x squared plus x squared, and you can just do solve in your calculator. And down here it says they place a ladder against the wall and they want to know how high the ladder reaches up. So that's this height here. So generally kids can't understand that question, I don't know why, but that's what they want. So if I was setting up Pythag, it'd be 5.6 squared, because that's my C, equals the 1.5 squared plus h squared, and you can just do solve. Okay, so you guys can work that out. That's not too hard, I was just showing you.